Hello everyone, I am Queen Rose Avila and I will be discussing to you the chapter 3, Hydrology, which will be focusing on the environmental impacts of water reservoir. So before we discuss about the environmental impacts of water reservoir, first we will identify what is a dam. A dam is an artificial barrier usually constructed across a stream channel to impound water. It is a barrier that stops or restricts the flow of water or underground streams. What are the functions of a dam? First is dam prevents flood. Dams are built to suppress floods. Another is it supply drinking and domestic water. Also, it generates energy. Example of this is the hydroelectric power dam. And the usual function of a dam is for irrigation. What is the structure of a dam? So as you can see on the screen, that is an example of a structure of a dam. So the heel, as you can see on the lower side, it is the contact with the stream on the upstream side, while the toe is the contact on the downstream side. The gallery is a small room-like structure left within the dam for checking operations, while the sluiceway is the opening in the dam near the ground level. It is used to clear the silt accumulation in the reservoir. Spillways is the arrangement near the top of the reservoir to release the excess water to the downstream side. Before construction, workers build diversion tunnel. This is to divert water before construction of the dam. This helps in keeping the riverbed dry. Classification of dams. Dams can be classified according to its size. We have the large dam and the major dam. Large dams are dams which are higher than 15 to 20 meters, while major dams are dams which are higher than 150 to 250 meters. Classification of dams based on its structure. First, we have the gravity dam. Gravity dams are dams constructed from concrete or stone masonry and designed to hold back water by using only the weight of the material and its resistance against the foundation to oppose the horizontal pressure of water pushing against it. Second, we have the arc dam. Arc dam is a concrete dam that is curved upstream in plan. It is designed so that the force of the water against it, which is known as hydrostatic pressure, presses against the arc, causing the arc to straighten slightly and strengthen the structure as it pushes into its foundation. Buttress dam, or also known as hollow dam, is a dam with a solid, watertight upstream side that is supported at intervals on the downstream by a series of buttresses or supports. The wall of the dam may be straight or curved. Most buttress dams are made of reinforced concrete and are heavy, pushing the dam into the ground. Another is the embankment dam. It is a large artificial dam. It is typically created by the placement and compaction of a complex semi-plastic mound of various composition of soil, sand, clay, or rock. It has a semi-pervious waterproof natural covering for its surface and a dense impervious core. Classification of dams based on its uses. We have the check dam, the detention dam, diversionary dam, dry dam, saddle dam, storage dam, overflow dam, wing dam, and a coffer dam. So let's go now to the environmental impacts of water reservoirs. First is the water loss. Our systematic overuse of fresh water, in addition to the already worsening effect of climate change, creates a need for artificial reserves. Dam would appear to conserve water by storing it, but the bigger picture shows this is not true. Generally, reservoirs and artificial lakes have a larger surface area than the rivers and channels that feed them. Larger surface area exposes more water to the sun, which speed up evaporation. And due to the nutrient-rich water from trapped sediments, dams and reservoirs also promote aquatic growth. The plant transpiration contributes to the already heightened evaporation rate. Every year, about 170 cubic kilometers of water evaporates from the world's reservoirs. These account for roughly 7% of all the fresh water consumed by human activities. Another environmental impact of water reservoir is that it affects the microclimate of the surrounding area. Dams also affect the microclimate of the surrounding areas, disrupting natural temperature fluctuations, ecosystems, and habitats. For example, increase in evaporation in the region of a large dam changes the moisture concentration of the air, leading to increased heavy rainfall. This deprives the surrounding area of their traditional rainfall patterns, placing stress on ecosystems and municipalities that depends on those patterns. And it leads to an increased rate of storm surges, which can create more frequent and intense flooding than the dam designed to handle. Additionally, dams disturb the flow and composition of the water within rivers and channels. Water released downstream from dams has a naturally high energy and very little sediments, which causes water to run forcefully, eroding the riverbeds, without sufficient sediment concentration to slow it down. This deepens the riverbed compared to the surrounding water tables, which causes the groundwater to rush into the channel and become surface water. This process is known as incision. Incision is a natural process in the life of rivers and channels, but exaggerated incision caused by rapid erosion results in the draining of the surrounding water. Dams also causes habitat destruction. Any dramatic change in river composition stresses both up and downstream habitats. Habitat loss is the leading cause of extinction. Dams disrupt fish and bird migration. The change in the composition of the river interfere with the chemical signals guiding species through their biological processes, and the physical barrier of the dam blocks species from their traditional spawning and rearing locations. As a result of this, pollution, and the effect of climate change, freshwater species have lost 76% of their population since 1970. Dams threaten the survival of the species that lives in the area. Changes in the timing and flow of the rivers can create conditions which threaten the survival of the species that have evolved to live there. Any alteration in the structure and composition of the river can have disastrous effects on the surrounding species, in many cases leading to extinction. Downstream habitats are also severely impacted by changes in salinity and oxygen. Due to the high rate of evaporation and growth of aquatic vegetation within the reservoir itself, water that travels downstream from a dam usually has a higher salinity content and a lower oxygen concentration than normal. This change in chemical makeup of the water creates detrimental conditions for the species that previously thrived in those areas. Dams also negatively impacts ecosystem and habitats upstream. Trapped river-borne nutrients can facilitate the growth of toxic algae blooms. Dams releases greenhouse gases. Study found that reservoirs account for about 4% of the human-made climate change. Most reservoirs, especially those in tropical regions, emit significant amount of greenhouse gases because of anaerobic bacteria that break down the vegetation at the base of the reservoir, giving off carbon dioxide and methane. Additionally, the changes to rivers' timing, chemical and sediment composition, and flow lead to dramatic variations in floodplains and wetlands, which can cause further destruction of surrounding forests. Dams also cause trouble to the people who live near or in the dam building site. Dam displaces around 80 million people worldwide, from the people removed from the dam building sites to the people who lost their homes due to the failed dams. Most of the displaced communities come from impoverished areas already affected by climate change. Actually, here in our area, the National Irrigation Authority also built dams, and it affected like 3 barangays, and the people in those barangays were transferred to a relocation area, and many people lost their farming lands because of the dam building. Old and failing dams generate both danger and costs. In 2017, nearly 2,000 state-regulated high-hazard dams need repair. These are dams that could result in high loss of life if they fail. And lastly, dams cause earthquake. Scientists have attributed over 100 earthquakes around the world to dams and reservoirs. This phenomenon is known as reservoir-induced seismicity. This happens when extra water seeps into the microcracks and fissures under the reservoir and surrounding areas and lubricates faults already under tectonic strain. So that's it, everyone. Thank you for watching and listening to my discussion. I hope you have learned something from it. Thank you and keep safe, everyone.